Welcome to the GeekNarrator podcast. Today we have a very special guest, Tim Berglund, VP of Developer Relations at Startree, and he had significant contributions in his role at Confluent. He's a well-known technology leader, speaker, author, teacher, educator, architect, surgeon, and novelist. Just kidding, because last time
I was
Tim
going to make
said,
that joke. I didn't remember if I said that last time, but when you list those things
yeah,
off, I always, architect,
yeah,
novelist.
I remember that. Yeah, Tim, welcome back on the show. I'm really thrilled to have you back. And this time we are going to talk about the world of real-time analytics and specifically about Apache Pinot and how all that works.
Yeah,
So,
thanks for having me.
yeah, let's start with the introduction again for viewers who don't know what you're doing currently and with Startree and Apache Pinot.
Yeah, sure. So I run the developer relations team here at Startree. Startree is a startup based in the Bay Area, and we build a fully managed cloud service based on Apache Pinot and other layers on top of Apache Pinot, like Startree Third Eye, Anomaly Detection, and root cause analysis tool, and other apps to come in the future on top of that kind of real-time analytics substrate.
Perfect. I guess we should start with the very basic. Let's not assume that everyone knows what analytics and real-time analytics mean. Probably our viewers know at a very high level when we talk about analytics. But let's define analytics and then a layer on top, which is the real-time aspect of it.
Yeah,
What do we
yeah.
mean by that exactly?
Yeah, I don't. Does anybody know what real time mean? That's the question. It's a slippery term, right? I mean, my career
Hmm.
started in firmware in the '90s when real time, in that then, but in that discipline, real time has a very precise definition, which means there's a bounded latency. Right? Real time system means that to process an event, there is a maximum defined time as a part of the specification. That's not what we mean. Latency is this is a database, so they're on a distribution. Define them probabilistically, and it's not that. And it's
Hmm.
not just fast, right? Because in the
Yeah.
kind of loose marketing sense, I guess people use that to mean, wow, we're fast. And that's not satisfactory to somebody who's trying to make a technical analysis. When I use that term, what I try to emphasize is that this is a database that's intended to do analytics queries in the loop of user interaction. So I interact, let's say I tap on something on an app on a mobile device, and that tap kicks off a query to a database that is an analytics query. Define that in a moment. I get results back and I see them. And so my expectations as a user, I'm basically synchronous, right? I go like this and I wait and I see a thing. I
Yeah.
don't go like this and put my phone down and I get a notification later. I want the thing to feel alive. So
Yeah.
fast enough so that in that user interface, it feels alive. Not everybody couples the definition of real-time analytics with user-facing analytics, which is just what I
Mhm.
just defined. But I think that's the easiest kind of entree into the term, and best way to get started with. Now, may I just back up and define what I mean by analytics also?
Yeah. Absolutely.
Yeah, we'll start with a little history and then attempt a definition. Commercial computing began in analytics. The first
Mhm.
companies that bought mainframes in the 1940s were buying them to do analytics. And it was always a batch process. There was a big pile of data put into punch cards, and you'd feed them in, and it would group and aggregate and spit out, put a bunch of numbers in, and you get a smaller set of numbers out that you can look at on a report and think about. So
Mhm.
commercial computing started with analytics. That has a history, moved along. You had data warehouses in the late 80s, early 90s. Then you had Hadoop and what eventually just became the data lake in the 2010s. What's common among everything throughout this history is analytics is about looking at many things and reducing them to something simpler, summarizing many things.
Mhm.
So at the database level, if you've got an analytics database, it's going to specialize in scanning lots of things. In contrast to a transactional database, which is going to specialize in reading or writing one thing. Now, these things are fuzzy, okay? We can perform analytics in transactional databases. Probably all your listeners know how to do a select group by and run an aggregation function. That works in any database. But a
Yeah.
transactional database isn't optimized for that scanning. It's optimized for this one thing. And an analytics database is optimized for these things, scanning and running some reducing function across some number usually. That's what we mean by analytics. Or more broadly, analytics is about trying to understand what has happened and get insight into what has happened. That's the very top level conceptual definition. And on a more technical database level, it's about being real good at scanning stuff and reducing some measurement to a number, or usually to a scalar of some kind.
Yeah. Yeah, I think that makes perfect sense because the transactional systems, we are dealing with one record, like one transaction. And as you said, for analytics, we are dealing with a lot of data and then figuring out the insights from that data that can help drive my business decisions. So that makes sense. So now we have a good understanding of what analytics mean, right? For the real time aspect, I assume that reading a lot of data and scanning over a lot of data needs to be efficient. Is it defined best in terms of the speed, or it depends on the use case? Can we give it a metric in, let's say, millisecond or a second or minute?
I want to say it depends on the use case for the actual numbers, okay? Because for, say, query latency, one use case might define a P90 of 100 milliseconds as adequate, or a P75 of 100 milliseconds. And another use case might say, I need a P90 of 20 milliseconds. And those are horses of different colors. It's hard to get from the one to the other. They're both the kinds of things that real-time analytics database ought to be able to deliver within some constraints, depending upon the kind of query and the index and all that stuff. But I don't want to say there's this absolute or that this is real time. But I would say there are three kind of characteristics, non-functional characteristics of the database that are interesting when we're trying to divide the world up, right? Because like I said, we had this evolution, you had mainframes, and then you had client server open systems, and that gave rise to data warehouses, and then they didn't really scale with the web. And so now we have data lakes and all of these technologies that do analytics on the giant piles of data we have in S3. And those technologies are designed around dashboards. That's the end goal, is let me have a dashboard that shows a leader, or maybe not such a high status leader, maybe just somebody lower in the organization, but a dashboard that shows the current state of things. If that dashboard refreshes twice an hour, man, you're great. That's wonderful. Queries take 15 seconds each to run. That's fine. So all that set of technologies have evolved around those requirements. And how many people are really viewing that dashboard? Not that many. So three things, I think, help us define the real-time from the not real-time databases. And those are concurrency, latency, and freshness. A real-time analytics database should expect very high query concurrencies, numbers of queries per second from 10,000 to 100,000. So orders of magnitude, 10 to the 3, 10 to the 4, 10 to the 5 queries per second, which is, don't do that to your data lake. You're going to have a bad day. Because, as I said, this is likely user facing. So we have a much larger population of people who are going to look at the queries. So very high query concurrency. Latency, we talked about that. They have to be fast because I'm interacting. I'm doing something, giving some command to a UI. I'm expecting a result. So I want latency in the small numbers of milliseconds. And freshness, I want to be able to ingest streaming data and have it be queryable basically right away and not have a batch process that pre-computes or caches or doesn't like that.
That makes sense. And that brings me to the next question, which is, so analytics did exist before Apache Pinot existed.
Yes.
And there were systems who used to specialize in that area. So what is the fundamental difference between the traditional analytics systems or the databases and Apache Pinot, which is the modern real-time analytics system?
Yeah. There's a number of ways one might slice and dice the question. And so I'm going to give mine. And if you're listening and you have a different way of looking at this, I would love to hear about it. But I think it has to do with the way storage and compute are coupled and the way compute resources are allocated. Those are their two dimensions. So we could make a quadrant here if we wanted to, which means we must be onto something. Look at a modern query federation engine, say Trino. And so there's various data sources that can be accessing. I can do complex joins between different kinds of things. And one of its assumptions is that it doesn't really know where the data is. It doesn't want to have a lot of strong opinions about that. It's often a data lake. It could be a legacy HDFS thing, could be S3, could be various different formats in S3. It doesn't really want to tell you how to live. It just wants to do the querying. And so storage, it's very agnostic about storage, and it's doing compute in this decoupled way for reasons. Okay, now there are things it's able to do that something like Pinot is going to have a harder time with. So this is not a criticism of Trino. This is this is a set of engineering constraints and decisions that it makes. Because compute and storage are decoupled, you're going to have a lot of flexibility in where your data is going to be. You're going to have not all that much performance. You're not going to have real-time performance because of that decoupling. So in the case of Pinot, it's going to, as sometimes I've gotten the question, what does Pinot use for storage? Is it Iceberg? Is it Hootie? Is it? No, it's Pinot. Its storage is its own format. And in general, it is tightly coupled to compute. And we can talk about the architecture, the different components of a Pinot cluster, but there's the one part of the cluster that really does the query execution, the filtering and the scanning and the execution of the aggregate and all that stuff. The data that it's accessing is locally attached SSDs. So the very highest bandwidth connection possible there. That's how you get that done. Asterisk on that, and double asterisk, because I'm not talking about the open source thing now. I'm talking about Startree cloud product, but we've got a cool tiered storage thing where you can offload old data into a cloud blob store in a surprisingly efficient way, but you pay a penalty. You're not going to get 50 milliseconds anymore. You might get 500.
Yeah.
I think that's the big difference, is that storage and compute are tightly coupled, and compute is always pre-aggregated. It's not like I'm going to go find workers and spin up tasks, and in the Hadoop tradition, go send my compute out and find places where it can go run. Nope, got it right here, going to run right here. So you pay the fixed cost of building all those resources in a cluster, and then you get this very low variable cost of super fast, highly concurrent queries.
Yeah, that does make sense. And I have some questions there. But before we dive deep into the architecture of Apache Pinot, I have a question, which is, as part of this, the entire process, like how we are able to achieve this real-time analytics queries, we also want to be able to ingest a lot of data, and that itself derives the freshness of the data. If I'm not able to ingest, if there is no mechanism to ingest the data at that pace, I'm not going to be able to use the power of the real-time analytics database. So if, let's assume there was no Apache Kafka, would Apache Pinot get up to its full power? Because ingestion is a key part of it, right? Was Kafka in a way a trigger to such a technology like Apache Pinot?
No, short answer is yes. And if you look at the actual history of Pinot isn't even the first real-time analytics database to have been developed.
Yeah.
But its actual history is LinkedIn built Kafka and began its transition, and I think had properly made its transition to being an event-driven architecture. And then they realized they needed ways of asking what has happened. Or to put it a little more concretely, you need to be able to query logs. Logs are not queryable things, but now we need a query layer on top of topics that maintains the real-time characteristics and nature and kind of wood grain of the rest of the system that they built. And the team built Pinot. And that's how that actually happened. So if you look at other players in the space that come from ad tech or web analytics or things like that, there were other event streams that were happening before Kafka was a thing. And so those other players, ClickHouse or Druid or something like that, they in those other spaces and maintain the shape of ad tech in their use case and what they specialize in. So I don't mean to overstate the case and say there wasn't anyone processing events in real time before Kafka achieved top level Apache status. That's just not true. But certainly Kafka is now a very mainstream, very broadly adopted technology. Event-driven architecture is a tidal wave that is sweeping through our lives, and we can deal with it or be swept away. And so given that, now you've got really the rise of these technologies as credible things. And I don't think there would be the kind of demand for this stuff if we were in some part of the multiverse where everything was still a monolith and we did everything in batch. So a
Yeah.
multiverse where there were no mobile devices and I don't know, some other things would have to be.
Yeah, that makes sense, and that gives a little context as to what is the prerequisite for being able to query data at such a high throughput with high performance, and Kafka does play a big role there.
I want to actually just put a footnote on that. It's technically possible in our world if you have no Kafka in your life and you just have batch sources of data that you
Mhm.
want to ingest and make them queryable very quickly at high concurrency. Freshness isn't your game anymore. It's all batch. But
Yeah,
you can import batch data into Pinot. It's not like it doesn't work. It's just
yeah,
I think the real meaning and significance and driver of the use case has to do with real time.
and that's what it is optimized for. Otherwise,
Mhm.
if we remove the real time aspect of it, would Pinot be still useful, or it will become another data warehouse?
Yeah, I don't think there would be a reason for it.
Okay.
Analytics is already a super crowded space. There's so
Hmm.
many technologies. And
Yeah.
if you look at early stage startups and the economic conditions we're in right now, as you and I record this in May of 2023, it's not a time of lots of early stage startups being funded, but there still are these early stage startups that have been funded in the last few years. A lot of them are in analytics. It's so crowded. And a lot of that is oriented around some little corner of how to be a better cloud dashboard engine. And boy, that's already being done. So
Hmm.
without the pressures on us as builders of systems and the pressures on businesses to do things in real time, or to transition to this event driven world, I don't think Pinot would make sense. Honestly, I think it
Hmm.
exists because those things do.
Cool. I think it's time that we try to go deep into Apache Pinot and look at its architecture. So we can take an example, let's say an e-commerce application, because it's so common. Everyone knows about e-commerce, how that works. Let's say there's a lot of orders coming in. There's a lot of search events. There's a lot of clicks and things happening all over your website, which is an e-commerce website. There's inventory and management and tons of events. If we talk about the entire business, and let's say I'm a CTO of that company and I want to make sure I have a system that supports me with real time analytics so that I can make quick decisions and also support my user facing analytics and something like that. With this, how would Apache Pinot look like from a technical perspective? Let's say I have Apache Pinot, I have all my events distributed across different databases. Let's say there's a relational database, there's like a Cassandra cluster, there's something else, there's some events in Kafka. How do I get all of it into Apache Pinot, and how does it look like from a
Sure.
technical standpoint?
I guess we can start with the integrations. In the case of the Kafka integration, Pinot and Kafka grew up together. So there's a native Kafka that you don't even use Kafka Connect. Pinot is a Kafka consumer.
Yeah.
So you configure what's called a real-time table to point to the Bootstrap server and credentials and topic name, and you ingest, and now you have a table, right? So that Kafka topic turns into a Pinot table, pretty straightforward. You mentioned Cassandra. There is a Cassandra integration. If I'm not mistaken, Cassandra, you can have it automatically create like a kind of a sidecar table. They don't call it that, but this little table on the side that's its own CDC feed. So it like does its own
Mm.
change data capture. This
Okay.
table gets populated with a list of the mutations, and then you can ingest that. And so you've got events, and you can ingest that into a table. So Cassandra is easy to pipe in there. Relational databases, again, solutions for that all change data capture. So we can get all that data into tables in Pinot. Now, there are a couple different ways that might happen. Some people might choose to get those things into Kafka because you might have one topic that you want to enrich with another, you want to join, right? And if we're
Mm.
trying to get things done in 50 milliseconds, you might want to do that join on ingest.
Mm.
So effectively, you could bring sources into Kafka, and then with a Kafka Streams job or a Flink job or one of the other streaming SQLs, do that enrichment, creating the topic that you're actually going to ingest, right? So you might have a few topics coming in, a little bit of stream processing, and now ingest this thing. There is, again, at the time of this recording, pre-production support for arbitrary SQL joins in Pinot, whether, and those will be production in a few months, probably, something like that. And whether you'd want to use those in real time, in the loop, or denormalize in advance, again, engineering decisions. But as joins, you might get those things figured out. So you got the data, it comes in, turns into a table. Do you want to go down to the physical architecture level now, or where?
Yeah. What's happening when I create a table? So just for our viewers, right? Like when we say a table, we don't want to get confused with a relational table, right? Like how does
Right.
that look like? Do all my fields live together in a relation, or it's done differently?
Your conceptual modeling of the thing in your head is going to be a lot like a relational table. It's a table.
Mhm.
It have columns,
Yeah.
they have names, they have data types, there are rows. You're going to think about those rows. Now, you define the table in JSON. In the case of Pinot, there's no
Yeah.
highly customized create table statement. We just said, you know what, that's enough. It's
Yeah.
create table options, blah, 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 blah. It's JSON is you're no worse off. So
Yeah.
a little bit different, the same concept. Okay. Now, the way it's actually stored in the cluster, here's where things get interesting. Number one, a table is physically broken up into things called segments. And those segments can be scattered around different servers hosted on different hardware across the cluster. Remembering that we want compute and storage in general to be tightly coupled. Those can be anywhere. And so we can scale out, we can have very large tables. But inside a segment, the way that row is stored is interesting. Now, in a transactional database, which Pinot is not, remember, in a transactional database, we're always interested in the one thing. I want to write an order or look up an order. We're usually looking at one, and you want that whole entity. So in the storage, you want to store all of those column values all together, because I want to be able to go to here in storage and read this whole chunk and bring it in. Now, I'm usually not interested in the whole row in an analytics query. There are going to be a few columns that are the dimensions that I'm filtering on. And I will need to maybe do some reads of those things or use indexes to figure how is it that I want to do my filtering. Because ultimately what this analytics query is going to do is there is some column, and usually call that a measurement, and I want to scan a bunch of values of that column. Now, I would like to avoid as much of that scanning as I can, right? I'm assuming that accessing IO is expensive. And if I can not scan, I'd like to not scan. So we're going to try to use indexes to minimize the amount of scanning that I do. But the bottom of this whole process is, okay, it's this order value, the average order value for orders in zip code 80002 on July 17th this year, whatever, something like that.
Yeah.
I need to read that average order, that order value, so I can compute the value. And so the storage in a Pinot segment is not here's a whole row altogether, but it's here's all the values of a column altogether. And so you get user ID and shipping postal code, all the values, and then order amount, all the values, tax, all the values. So it's like a column-oriented database. And that's because, again, in an analytics query, we're scanning a number of values, and we would like those all to be in one place so that I can just maybe read a few blocks off of the device efficiently and have everything.
So we will talk a bit more about the indexing, because that's the core of making the queries faster. So
Yes.
in terms of ingestion, it's pretty clear that I want my data from all these different sources into one place, something like Apache Kafka, which is very easy to do these days because I have CDC, I have event streams from different databases. So I have multiple topics. One important thing that you mentioned was whatever pre-processing I want to do and the joins I want to do before I ingest the data in Pinot. So that seems like a best practice to do, right? What would happen if I don't do that? Is there join facility available with Apache Pinot?
Yes. So in the current version of Apache Pinot, current release is 0.13, there's pre-production support for what we call fact-fact joins between two really big tables. And there's a whole new query engine that the Pinot team is building to be able to support that. That's moderately game-changing in its own right, but those are not production ready yet. That's probably going to be a few more months before that's a fully baked feature that the Pinot team is recommending for production use. But yes, there are joins now, and they will be ready soon. Always going to have a performance penalty on that kind of thing, though. That's a more complex query. There's just more work to do. And so that's unlikely to fall into that sub 100 milliseconds kind of range if you are doing complex fact joins in your query. So it's good to have that there, but there are going to be still forever use cases where you want to do that enrichment in the stream processor. Now, that I want to talk about that enrichment in the stream processor. It's as much about enrichment, which is join, filtering, you mask off PII, make sure the wrong stuff doesn't get in, all that kind of stuff. You don't want to really get in the habit of pre-computing things that you don't have to. And there are teams that do it, like every engineer gets to make that choice. There are times when it's justified, but you don't want to think of that stream processing layer as, oh, I have these aggregates, I better pre-compute them so they're fast. There's no particular reason to think that's the path we need to go down, right? If you get yourself into that situation and it makes sense, fine. But Pinot's already real good at that. And so you're better off ingesting the events and having flexibility to do what you want with them later. And we'll talk about, we get to indexes, we'll talk about an index that does some pre-computation that you don't have to code.
Yeah, absolutely. As a CTO, I might think that, okay, let's say I don't have the expertise of building a Kafka stream application, or let's say a Flink stream application. And I might be okay if there's a performance penalty if I do all these processing and aggregation or joins for that matter in Apache Pinot. So that is also an option, right? And but maybe the best practice is to just hydrate or enrich your data before you even ingest. So it's ready for, as soon as it reaches Pinot, it's ready to be served. And I think that makes sense in most systems. But of course, as you said, there might be some use cases where pre-processing is maybe not an option, and you might be able to leverage joins that Apache Pinot is going to support.
Yeah, I think as much as one can express a general principle for this kind of thing, it always depends on the specifics and the constraints and the business results you're trying to. This is why we have engineers. But as a general principle, don't feel like there's some pressure to pre-compute. There is explicitly not pressure to pre-compute. That is the old way, and we would prefer not to if we can get with it.
Cool. I really want to jump into the world of indexes, but I have another question.
Okay.
Since I'm running this e-commerce company since, let's say, 1 year, right, and I'm going to migrate to real-time analytics database like Apache Pinot, I have a lot of historical data as well, right? And I want to dump that data as well in Apache Pinot. Let's say for some of the queries that real-time analytics might also get changed or impacted by the historical data that I have. So I want that data as well. So how do I do that?
So there's a way of ingesting batch data, and then there's a way of ingesting real-time data. And it occurs to me, I'm slightly fuzzy on I haven't actually built one of these, so the details of how it all works. But yes, the short answer is, of course, if you've got not legacy, but just historical batch data and then real-time data you're adding on top of that, of course, that's doable.
Cool. Now I have all my data. I have the integration done and my data is reaching Apache Pinot. Let's say I have a table. I'm like writing some queries and it's not that performant. And I want to know what kind of indexes I want to create on them, right? So one, what are the types of indexes available? How do they work? And two, is there like an automated indexing system that is happening inside the Pinot? Based on the queries that it is getting, it might create these indexes on the fly and give you some performance boost.
Okay, start with the last one, the AI index recommender thing. Not yet. Sounds like a thing that Pinot 2.4 might have someday or something like that once we're a little farther down the line. It seems like an obvious thing these days that you'd want to do that, have some ML in there and just make some good choices. There is this isn't even proprietary. You can use this for free, but it's part of Startree Cloud, the Startree Data Manager, and there's a Docker image. You can run it locally and even use it in production under most circumstances for free. Startree Data Manager is an ingest tool, and there are some improvements in the works there to just try to suggest good indexes for you up front. It's not some super AI-based real-time optimization thing, but it's good choices. So for now, let's just assume you know your data and you want to know what indexes you've got, and you're writing your config file and you want to define indexes on columns. So let's just talk through a few of the indexes. There are some basics that are almost mechanical, like the forward index and the inverted index. The stuff that you're likely to use a lot in subtle ways, there's a text index. And you can think of that like a little embedded Apache Lucene. So common text search kinds of things that can just be terms, combinations of terms, phrases, partial matches, regular expressions. If you got a good text blob and you want to do text searching in there, there's a text index. There's a JSON index. So if you have a column whose value is itself complex nested JSON, you can create an index on that field and performantly query it in interesting ways. If there are arrays, I can index into arrays. If there are nested structures, I can define a predicate that in terms of the nesting, a good kind of the JSON index you wish you had is really what it is. It just does what you'd want with JSON. There is a range index. So suppose you have just something that's a number and you want to, it usually varies between 1 and 1,000 and you're interested in that by hundreds. You might want to know if it's between 300 and 400. I want to filter all those records. There's an index where I can define ranges of a number and then efficiently read. There's a timestamp index that is actually derived from the range index. Traditionally in analytics, you have the notion of grain. When there's a time field, you have grain that is like every second, every minute. I want to be able to roll up by the hour, by the day. So the timestamp index is a way of imposing a grain on the index that now I can performantly get filter to all the records that occurred within that hour or that minute or whatever it is. There's a geospatial index. That's its own whole episode that is going to be a different guest and not me because I'm actually not very good at that index. Something developed by Uber. Uber's a big Pinot user. Uber, LinkedIn, these are the big guys. But obviously Uber is concerned about the locations of things. So they took a geospatial library of theirs and turned it into an index. The probably coolest one, I think, most people seem to react this way, is the index called the star tree index. Now, my employer is named Star Tree. That turns out is an implementation detail that's leaked into the interface. And this is different. This is a part of Apache Pinot. It has nothing to do with Star Tree. We just thought it was a cool name. Use the name for a company. But the index is like a pivot table saved to disk. So if your query is an aggregate, like you always want to know, we'll say it was like smart thermostats as an example, the average temperature of thermostats based on what room they're in, what class of home they're in, and what postal code they're in. And you might want to know what's the average temperature for all of 80002, or all of the townhomes in 80002, or all of the thermostats in kitchens in townhomes, or something like that, right? There's different ways you want to do that. Fine, you can do that. Those would probably be inverted indexes on those 3 columns and then an average aggregation. And you could do that query. If you want it even faster, you build a star tree index, which does pre-compute that aggregate inside the index. And so it's not, I have to write a stream processing job and do this pre-computation before you still got all the data, all the particulars in Pinot. You do anything you want with them. But I know I have this query I want to optimize. And so in the index itself, it actually does the pre-computation. And so reading from the index is getting the result. I never have to then go scan anything in the table. I've got the number that I need. And as long as I use the predicates in a particular order, I can all of the zip code, all the townhouses, all the zip code townhouses, kitchens, and the data is all there. So it's just a cool index because, benchmark it and it looks like it's fake because you get really fast numbers out of it.
Yeah, that's a good summary of the different types of indexes available. And as a CTO, I'm thinking that all my e-commerce queries are going to be supported with all these indexes, right? For example, if I want to find some range of the product prices that the products that were ordered, let's say in last 1 hour, what is the average basket size or the cart size? I can do that, right? If I have to track the inventory and for certain products, of course, I can do that using, let's say, inverted index. For geospatial, maybe if I have to track something on the delivery of the items to my customers in a specific zip code, or how many delivery agents are delivering at this point in a certain zip code. So that could be a use case for that. For starter index, what could be a good use case in this e-commerce system?
Yeah. You could have, let's say, country and then region within country. And then maybe you've got some customer class assignments, like you've got your MVPs and your new registrants
Ah,
and activated people and something like that. So if you're always trying to find out what the maximum purchase is of the newly registered companies in Nevada or customers in Nevada,
mm,
then you're going to get that, or you want to compare that to Rhode Island because you just have a real heavy physical footprint in Rhode Island. That would be an index that would make that query fast.
yeah.
And
Since we are talking about indexes, right? Like whenever we are talking about indexes in terms of any other database, we are a little worried about the write amplification that happens, right? Because when I'm ingesting data into the database, if I have 10 indexes, I have to write or update those 10 indexes as well. So how Pinot tries to mitigate the risks of write amplification with all these indexes? Because
yeah,
as a
so
user, I can go ahead and create as many indexes as I want if I don't worry about the cost and all that. And that might impact my performance in some way. Is that happening, or there are some optimizations?
there are, and it's always the case that more indexes means more storage, more compute on ingest. So if I'm
Yeah.
doing batch ingest into an offline table, which just means it's from batch data, it doesn't mean that process is going to go slower. It's going to take me more time. I'm going to use more space. It's never free, right? In the transactional sense, the time it takes me to commit a write is affecting how long it takes me to process. It's usually a form submission is usually an event or some kind of click to order or something like that. And I'm a little bit more nervous about that write time then because it's, at least historically, has been synchronous. This whole thing, I'm in a big hurry to get done because the user needs a new page served to them. This is terribly old fashioned thinking here. I need that query, that write to be as fast as it can be. So careful with the indexes. And that's a valid optimization in the transactional
Yeah.
case. A lot of that, I think, these days is going to be a lot more asynchronous in the case of a transactional write, but you still don't want it to take forever. Now,
Yeah.
in Pinot, in ingesting into Pinot, let's put the batch case aside because that's that ingesting data into an offline table. It takes 15% longer because I got carried away with indexes. Sorry, that's not that bad. In the real-time case, what's happening on ingest there is it is being written into a thing called the consuming segment. So that write happens to a component called the Pinot server. There's lots of Pinot servers. And this partition of this Kafka topic is assigned to this server. And that ingest is again is a Kafka consumer internal to Pinot. It is consuming, it reads the message and advances the offset that it wants next. And having read that message, puts it into the consuming segment, which is an in-memory structure. And so are there the in-memory equivalents, data structure equivalents? Yes. And is there extra compute and extra space associated with those because there are extra indexes? Yes. Is it a big deal? No, because you're still dealing with that one message. It's in memory and you don't feel that pressure quite as much. And then, but by the way, that consuming segment, when it fills up, we write it to disk as a segment. And that writing to disk process is asynchronous. Again, there's just less stress on the whole thing, which is not to say that indexes become free. They never are. We are
Yeah.
engineers. We have to make trade-offs and use them judiciously. But I think the legacy, oh no, I have too many indexes, my writes will be slow thing is just a less urgent concern.
Yeah. That's a relief, because I still have to be cautious that I don't create unnecessary indexes on my data, but because it's not free, I still need that education. Like, how do I create those indexes and what makes sense? If I'm not never going to run a range query, it doesn't make sense for me to create a range index. That could be a
Right.
case.
Don't do that
Uh,
thing.
But I think it's again boils down to think about the use cases that you want to solve, think about the queries that you want to run, and then create indexes. And not because, oh, I have data. I ran certain query because I have access to Apache Pinot. But if your customer is never going to use that, it doesn't make sense. When we started off describing the differences between a transactional and an analytical database, we mentioned that in transactional database, we want to deal with one row, one item at a time. And with analytics, we want to deal with a lot of data and figure out something. What happens if I want to run point lookups on Apache Pinot? Is that recommended? Is that going to be slow, or what is happening there?
No, it is a doable thing. So you adopt Apache Pinot because you want a real-time analytics database, right?
Yeah.
If you want a database that does point lookups, get you some Postgres or Cassandra or something if it's big. There are ways,
Yeah.
there are systems that are optimized for that. But what we get into is my data's here because I need a real-time analytics database. And now I need to do this thing where I need to do a point lookup. And that's completely fine. Of course you can do it. That's doable. And it's not going to be like hideously slow. I don't like to talk about benchmarks and numbers just as a matter of course. And I don't know actually any numbers on point lookups. It's just not a typical thing, but there's nothing architecturally that makes them impossible or so expensive you just wouldn't consider it. If that use case comes up, do it. It's the thing that gets you into hot water isn't a point lookup. It's what if I want to return lots of rows? And there's kind of orders of magnitude there. In a transactional database, typically those are fairly mature products. You get paging, you get all kinds of, I need to go through every single row in my thing. And it's not going to be fast, but I need to return the row, do compute, and then get the next row and do compute. You can do that kind of thing in Pinot also. And it's just the order of magnitude of the number of rows that's going to tell you whether you're where you need to be. If it's in the 10 to the 2, 10 to the 3 rows, 100, 1,000, that's okay. If it's 1,000,000 rows, you need to get all those 1,000,000 rows back. That starts to make the people who operate Pinot a little uncomfortable. It's not so much point lookups as iterating over large sets that gets you into maybe this is not the right place for that kind of data access.
Yeah, that does make sense. And I mean, it's okay to do point lookups if you really need to, and you don't want to put that data in some other database, but it's not going to be that performant. And it depends on the number of rows you're going to hit,
And
right?
it's okay to do analytics in a transactional database.
Yeah.
The technology supports it, and it's not going to be concurrency and latency and freshness. Those kinds of things are not going to be where they are in a system optimized to do that in a real-time way, but you're not bad engineer for doing it. It's a valid thing to do.
Yeah, sounds good. You mentioned, you wanted to talk about anomaly detection, right? What exactly does that mean? And let's say if you're going to talk about in e-commerce system domain, is it about detecting some fraud transactions that are happening on my e-commerce system?
Yeah, it could be, but anomalies don't have to be negative things. Maybe they're negative if you don't respond to them properly, but an anomaly could be on my e-commerce site, some influencer posted a TikTok about an item, and now sales of that thing are just spiking. And it's negative if you don't respond, but hey, I think anybody operating an e-commerce site would like that. So yeah, anomalies are just things that are different. And dashboards, if you think about dashboards, it's almost the purpose of a dashboard to enable anomaly detection. It's just that the anomaly detector is a person, and probably a highly compensated person with lots of demands on their time. So we make dashboards so executives can function as anomaly detectors. And I think that's maybe not a good use of human capital. And in these days of obsession with AI and large language models and what are these things going to do and what sort of jobs are they going to replace, asking people to memorize the wiggles of a line on a chart so they can know when the wiggles are different. That sounds like we should use computers for that. And when you look at highly dimensional data, it's not just one wiggle, right? It can be an anomaly with respect to many dimensions. And it's pretty quick to get to the point where you actually would need enough little line graphs on the screen that you won't be able to memorize what the wiggles ought to look like. So you need a machine to help you. So yeah, anomalies are just a difference in a measurement that's not the normal pattern. And Archery makes a thing called Third Eye, which is community licensed. So you can use it for free. You can also use the Startree Cloud if you want, but you can't call it open source because of the license of the open source initiative doesn't let people use that label, but it behaves like it's open source. You can get the source code and you can use it for free. So anyway, you put it on top of Apache Pinot, onboard a data source, which is just a table, and you say, okay, here's my measurement, here's my dimensions. Go look back over history and learn what the wiggles look like and tell me when they're different.
Okay.
And when they are different, that's cool. But the next question is why? And it will let you drill down into the dimensions associated with that measurement and look at what values of those dimensions contributed to the measurement being higher or lower than normal. This kind of heat map view. It's super cool.
Yeah, that does sound like an interesting use case. Let's look at what's in the future, right? Is there going to be like a ChatGPT plugin for Apache Pinot where I just talk to ChatGPT and it gives me analytics backed by Apache Pinot, or what's in the future?
Yeah, this is me speculating at this point. This is not me talking about a Startree roadmap or plans that the Apache Pinot Project Management Committee has. This is just the two of us talking and speculating about what might be. And it's funny, I just had a meeting with my team yesterday, the DevRel team, the day before you and I are recording this, where we were brainstorming about, okay, how are ways we could use ChatGPT, even in our online presence, our developer site and Slack, how can we employ large language models to take better care of the developers that we serve? And so in the future, it seems like those integrations are likely. I mean, anybody can hack this together, right?
Yeah.
Write the SQL for me. Here's my schema. Write the SQL for me that gives me this result, which I am describing in English. And my team, frankly, as we're discussing yesterday, what we do here, give me a table, a Pinot table config file based on the data. Here's a little snippet of a CSV file. That's my data. Now write my table config for me. There it is. There's the JSON copy paste. And like anything in an LLM, you have to look at it. You might still have to debug it. It might be confidently incorrect, but we're already looking at kind of those trivial uses. And I would even say that those are not particularly imaginative. Let me describe something and go write this code for me. Go manage all the details. That is level 1, level 2 kind of use of the technology. And we're trying to imagine what level 10 looks like. Not again from a product roadmap perspective, but what are cool things we could build on top of it? And if you knew everything in the Pinot and Startree docs and all of our blog posts and sample code, if you knew those things, and here's a question from somebody in the community, what resource would you point them to? Those are things we're thinking about. And I tend to come at this from a DevRel lens and less what could be integrated into the database itself. I would say it doesn't seem like LLMs are at this point properly real-time technology. Yeah, I don't know if you built your own and tuned it, maybe you could get better things out of it. But I think at least as a front end to help me write configuration and write queries, that makes a lot of sense. And in terms of onboarding actual real-time data streams into the model and that kind of stuff, that's a little farther out. And I haven't thought through that yet, but I would love to think through that with somebody. Sounds like a cool thing.
Cool. Yeah. Just talking about the features that are going to come up on Apache Pinot. What are some new features that are going to come up in, let's say, next release, or like talking about the roadmap?
Okay. Yeah, good question. Because that stuff is more or less known. And I actually don't quite know what's slated for 0.14. The big news is joins. Joins probably in 0.14 are probably still not going to be considered production ready, but that engine is moving forward. People are using it in production, of course. The people, early adopters do so carefully, but that's going to continue to get refined. And that's really the thing that you want to keep your eye on for now is joint support. And there's a number of other small improvements in this, that, and the other thing, but a lot of the efforts focused on that right now.
Perfect.
We do, and I could actually link you to this. This is just my bad memory at work here. We had a meetup about 2 months ago, a month and a half ago, as we record this, with a bunch of Pinot committers talking about the work they've got planned for the year. So I should send you a link to that. And if that can go in your show notes, then folks, you can watch that. And there's a companion blog post if you want to know the facts other than the things I remember.
Yeah, absolutely. I would love to add that in the show notes. Perfect. Tim, thanks a lot for joining me today and sharing the insights and your experience and the context behind real-time analytics and how Apache Pinot operates and why is it different. I'm sure it's going to get people started to think about real-time analytics for their systems, for their own use cases. And also they would try to evaluate Apache Pinot as a technology. Thanks for doing this. And I'm excited to release this episode probably in a couple of weeks. I don't know. But yeah, for our viewers, if you like this discussion, please hit the like button. Don't forget to subscribe to the channel and also share it with your network so more people know about Apache Pinot. And with the Real-Time Analytics Summit and the podcast that Tim is hosting these days, I think Apache Pinot is finally getting the love and the attention that it deserves. Great. Thanks a lot, Tim. And looking forward to collaborate with you more.
Always a pleasure. Look forward to the next time I get to be on your show. Thanks, Kai.